Next up, we're going to be talking about 3D vision and AI-based robotics solutions. And our next speaker is someone who is dedicated to advancing her company's mission to deliver intelligent automation solutions. And it's a company which has grown to become a prominent player in automation, particularly in the areas of 3D vision, machine learning, and AI-driven robotic applications. So, from Mech Robotics, please welcome on stage Managing Director Ying Wu. Welcome. Good morning.
Thanks so much.
Great to have you here. This is for you. Take it away.
All right. So good morning, everyone. I'm happy to talk about the exciting topic of AI-driven robotics now. We have already heard yesterday and today quite a few topics, great presentations about AI-driven robotics for the politics, from academia, and also from the very ambitious platform approach of incorporating all different approaches of AIs into really robotics. But at Mech Robotics, we are more focused on really the 3D vision-based AI for robotics. So maybe compared to the exciting, fun applications in academia, the bakery, and the rescue robots, and also the humanoids that can operate in a lot of space, we adopt more of a down-to-earth, pragmatic approach in using AI and 3D vision for robotics in manufacturing and logistics. So to start with, we use artificial intelligence in robotics really to interact with the physical world, in the sense that from these three aspects. First is perception. We use sensors, cameras, or other things to really make sense of the 3D world and let the robot, so that the robot can later on make decisions. Sometimes more decisions, sometimes less or more rule-based decisions. And in the end, for robots, you have to really interact with the physical world. That is, means the movement and the manipulation. And those are what we focused on. So from Mech Robotics, what we deliver, we are called Mech Robotics, but we do not manufacture robots ourselves. We use the robots available and equip them with 3D cameras that can produce a 2D color texture image and also depth image or point cloud with high precision that goes under 1 millimeter accuracy. And we also provide the machine vision platform that offers modular algorithms, including the traditional machine vision algorithms, like, for example, this model-based 3D matching, and also the current more deep learning-based, like segmentation and classification. So the idea is that you can program your own vision application with all those algorithms. And of course, to manipulate the robot, we also need a simulation software and the task programming software, since a lot of the times the environment is unstructured. You just cannot pre-program everything. And so about the company itself, we are a startup or maybe scale up. That's a new word I learned. We're 8 years old, and we have already delivered more than 10,000 really real-world applications to different branches, industries in manufacturing and logistics, and also across the world. We have offices in the US and Germany for Europe, and also South Korea and Tokyo, and of course China. Yeah. So this is the brief introduction. And like I said, we go more the pragmatical way. So what I'm going to show today are really the actual real-world applications, examples. The machine tending for bending process, the picking transparent bags for medical usage, and picking of bolts, and item picking. None of them are so fancy, but the good thing is they are really running in the production in large scale as we speak. And the first example is really machine tending for bending process. We know that this process is quite really challenging in heavy industries because it requires high precision in bending, and also the steel plates can be unsorted and mixed. The steel plates need to be recognized based on their type, which can be really similar and also symmetrical. And we can see from this picture, very often the special parts, they're challenging to center due to their weight. And the size tolerance can be also large. So these are the challenges for the traditional machine vision algorithms. But with the help of deep learning or AI, these can be now more tackled and really be implemented. So, as proof, it runs like this. Since we are not allowed to really make a video in production, this is a video we took while we were still doing commissioning. That's why the speed is not in the real time. But what we can see here is, even with the traditional industry applications, and we don't always have to adopt the whole spectrum of AI. Sometimes it's just the few challenging steps that we can use AI to already help stabilize or make this process possible. Yeah. Next example is picking transparent parts, which is also very challenging for vision. So with the help of a combination of traditional vision algorithms and also the deep learning, for example, instant segmentation, the combining these two methods can help enable this into real-world application. The next thing is, how can I? No. Bin picking. So bin pick. I think a lot of you or everyone of you have already heard of bin picking. It has been a topic in the academia, in the industry for a long time. It has been also described as the holy grail of robotics because you need planning. You need to recognize the parts, identify the 60 pose of the parts, and then also do the decision making, like which one to pick first, and which one, what are the order of picking them. And also, to pick them more successfully, you have to also have this collision-free path generation for the robots to avoid collision with other parts, or the robot, or the end effector, or the bin. So this is a prime example of how you can use AI and vision to help doing application that was previously not possible. And in this case, it's still the more easier version of bin picking because the structure is easier. It's also consistent because it's a same type of the parts. So we don't have any mixed parts in the bin. So some people might also say it was also possible, or it is possible without AI. You can just use 3D vision and you have a CAD model, you can match them. But the problem is, a lot of times, especially when it's random bin picking, when the parts are somewhat bigger and the bin are deeper and smaller, then a lot of times it's not robust enough. So very often you encounter the cases that it's not pickable anymore. So you have to shake the bin, or you have to have someone who manually flip around a little bit. So the great thing about the deep learning or AI here is exactly to increase the success rate of recognizing the right part and giving the right instruction. And also in planning the order of the picking. In the past, you can only do rule-based, like I only pick, or I pick from the highest to lowest. Or I pick, sometimes when they're overlapping, I say I pick the ones who are, which are the most free. But with AI now, you can also do it with data, with experience. So because a lot of times it's difficult. It's unstructured environment, it's a dynamic environment. You cannot always define a rule that always works. Yeah. It's the same with the path planning. And it sounds trivial, but a lot of times the deciding points is really, do I, after picking this part, do I go 3 millimeter further or 4 millimeter further? Do I go from this angle or this angle out of the bin? But that's another thing that you can use the automatic generation of the trajectory. This time, it's not even necessarily deep learning. It's another, maybe a search algorithm that's also a part of AI. Yeah. So the next example I want to give contains more AI. Because this kind of bin picking or item picking is about unknown objects. Here, what the robots pick are all the objects we can get from supermarkets that are previously not seen by the system. The system has no idea what it's picking, but from experience, it has been trained so many times. So from the experience, it knows, OK, this is the objects I see, and what could be the appropriate grasping points for my system. Yeah. And of course, the order arrangement and the path generation is also, from bin picking, is also used here. So we saw from the examples that from different applications, there are also different levels of involvement in AI in these things. So from the very first one that we actually only need very simple classification and identification, to this item picking where you need really sometimes from end-to-end training, from the data to the grasp point already for the training. And what we think is, or we want to state as message is, well, it doesn't always have to be the fancy AGI that comes with robots. But it can be just a technology that is pragmatically used for the problems, that industrial problems that need to be solved. You just analyze your process and identify what are the challenges. And this is a technology that you might be able to implement to solve these challenges or problems. Yeah. And another bright future, I would say, is, of course, also this generative AI. What we want to say is maybe you also don't need to always use it for always dynamic, on-the-fly generation of movements. But for manufacturing, you just need to use it for commissioning the process, and also to do adjustments when you have new parts. Yeah. That's wrap up of the presentation. And thank you very much.
Thank you.
Thank you.
So, we also have about 5 minutes before our next break. So, does anyone have any questions for Ying-Wu at all? While you think about it, obviously you've come a long way. What would you say are the biggest challenges in implementing all of this?
Yeah, I would say especially the adoption of this technology. In the beginning, although we started in Asia, well, luckily a lot of customers are more willing to try new technology. Even in the beginning, the success rate might not be too high. But we deliver the solution, do fast prototyping, and we try, and also practice with the customer together, and improve, and improve, and improve. And later, it runs really stable for years. Mm-hmm. But in Europe, where the industrial or automation happened much earlier, and it's more mature in the industry, we realize the customer are more willing to adopt mature technology. So they are saying that it has to be meeting these requirements, the cycle time has to be this, and it has to be ease of use, that we can, for example, adopting a new part within a few hours. So what we see is really this reluctance to try new stuff, that they're more willing to use technology that they have been using for decades. Yeah.
Okay, thank you. Yes, here at the front, thank you.
Yeah, thank you for your presentation. You mentioned in your last sentence using AI for adapting to new parts. What is the procedure actually like if a production changes and new parts come in? Is there retraining? Is there a recollection of data? How fast can the machine be tending again or picking again?
It really also depends on what the parts are and how it looks like and how similar it is to the previous parts. For example, if it's the bolts, what I showed in the third example, you have a bolt that you're already using. The new parts is a bolt of a different size. Then in this case, you don't need to train again, because the current model can already generate fight to the new model. But if, for example, if the new part is very different, or quite different in shape and also in material, because that reflects the quality of the pictures and the point clouds. So in this case, you have to collect new data. In our case, we also have a training tool for it, so you need 30 to 50 different images that also ideally cover different conditions, how it looks in the bin, and then train it for a few hours to a day, depending on how the complex it can be. Yeah.
And that is then based on a base model and basically fine-tuned, or trained from scratch for every new item?
For some items, we have a base model. For example, screws or the simple geometry stuff. But for complex, unstructured type of parts, then you need to train from scratch.
Thank you.
Thank you so much.
Thank you. Okay. If there are any more, I think Ying-Wu, also you'll be available during the networking break. Wonderful. Then I think we can wrap it up there. Thank you again so much.